In this video, we are going to understand socket programming, and also we are going to understand how many different kinds of servers are there and what is the purpose of those servers. And also we are going to understand what will be the functionality or what are the functions I used in your socket programming. So whenever we'll talk about the socket programming, then we need to understand the architecture of client-server architecture. So we'll say it is so we need to understand what is a client-server architecture. So when I'll talk about the client-server architecture, we are going to have a computer here, and this computer wants to interact with another computer, or it wants to exchange some data between these two computers. So whenever I want to establish or whenever I want to send the data from one device or one component, one computer to another computer, so there need to be a communication line in between these two computers. So this communication line can be a physical line or it may not be a physical line, but we need to say that, okay, we are going to have a physical line in between these two computers. And whenever a computer or an electronic device, whenever it wants to send the data to others, it need to have an endpoint. Okay, so whenever I want to send the data onto the internet or whenever I want to receive the data from the internet, it need to have an endpoint. And we call this endpoint, which I used for sending the data, receiving the data from the internet, we call it as your socket. Okay, so simply I say that a socket can be called as an endpoint by which we can send the data or receive the data from your internet. So if you are going to send the data, okay, we call it as a sender, and if you are going to receive the data, then we call it as a receiver. Okay. Now a computer which is going to send a request or it is going to seek the help from another computer, then that kind of computer we call it as a client. And a computer which is going to give a response over the internet or it is going to solve the request given by the client, we call it as a server. And the combination of my client and server, I call it as your client-server architecture. So now we say that a client is a device which is going to send a request, and a server is going to give the response onto the client. So we call it as your client-server architecture. Now, and also we understood what is the socket also. And we are having only one endpoint. Means any electronic device is going to contain only one endpoint, but this electronic device can have multiple applications. So we are going to indicate these applications by using the circles. So now we'll say that now we are having 5 circles here. It means that in this computer or in this electronic device, we are having 5 different applications executing on this computer. So for differentiating these applications, okay, from one another, so each and every application now is being identified by an integer, and we call that integer as a port number, right? So in this case, now I'll say we are having 5 applications and we need to separate those five applications. So for separating those 5 applications, we are going to assign an integer value for each and every application. Then we call it as your port number. Suppose I say we are having these applications executing on this computer, and now I want to interact or I want to send the data from this application to this application. Suppose I say we are going to identify this application as 1001, and I say this application as 001, 2001. So now we are going to send the data from this 2001 application, and the application is being sent through the socket. Okay, and then again we are going to receive the data through the socket, and whatever the data which is there on the socket now will be taken by this application. So we say a port number is an identifier which is going to separate the simultaneously executing applications then interacting with your outside world. So now with this information now, we are able to understand, okay, what is an IP address and also a port number. So this IP address lies at this point. Okay, so this socket at this point, we are going to have an IP address. So simply I say that an IP address is an identifier which is going to identify your computer over internet. Okay, and the port number is an integer value again, which is going to identify your applications executing on your device. So we need to have a clear idea what is an IP address as well as what is a port number. IP address identifies the computer over internet and port number identifies the application involved in your communication. Okay. Now, after understanding client-server architecture, after having the awareness about IP address and port number, now we go further and uh, we'll see how many different kinds of servers are there. So we are going to classify the servers as number one as iterative server, and the second type of server is called as a concurrent server. First of all, we'll talk about an iterative server, then we have few words on concurrent server also. So if you talk about an iterative server, so what the iterative server is going to do is this iterative server is going to serve only one client at a time. What it does, it is going to serve only one client at a time. Okay, so this is applicable, or this iterative kind of server is applicable when we are talking about your jobs. Okay, so when we have the task, right, if we are going to execute the task in the form of a job, then we are going to take the help of your iterative servers, and all the applications are, all the executions are being done in a sequential manner. It is being done in a sequential manner. So we have its own pros and cons of it, but we are not going to talk about the advantages and disadvantages of iterative server. First, we know what is the iterative server. So an iterative server which serves only one client at a particular instance of time, we call it as an iterative server, and all the executions are done in the iterative server in a sequential manner only. Especially, we are going to talk about the jobs when I have an iterative server. So in contrast with this iterative server, we have another type of server called as your concurrent server. So what this concurrent server is going to do is, so this concurrent server is a type of server that can handle, multiple clients, okay, and simultaneously. And this is a contrast to an iterative server, where the iterative server is going to handle only one request at a time, whereas the concurrent server is going to handle multiple clients at a single instance of time. Okay, so this is uh, the basic difference between the iterative server as well as your concurrent server. And the examples of these concurrent servers are, so we have your web servers, we are going to have the database servers, we are going to have your network servers. So all these types of servers falls into the category of your concurrent server. So now the execution of these processes, or the execution of all these concurrent things will be done in a parallel manner. It means that concurrent servers are going to ensure to share the resources in an efficient manner so that there will not be any kind of deadlock will be occurred while sharing the resources. So all those things will be taken care by your operating system. So now, for now, what we need to understand here, we need to understand that, okay, whenever I say concurrent server, it is going to handle multiple requests. And what are the examples of these concurrent servers? The examples of your concurrent servers are your web servers, then network servers, then your database servers. So when I talk about a concurrent server, whenever I get a request, suppose I say I have a server and I have a client. Okay. Whenever a client sends a request to a concurrent server, so what the concurrent server is going to do is the concurrent server is going to create a separate process for it. What it does, it is going to create a separate process. So just I like to show it by having a small diagram. So I call it as a concurrent server. So we have a client here, and the client is sending a request. A client is sending a request onto the concurrent server. So whenever the concurrent server receives a request from the client, what the concurrent server is going to do is it is going to create a process. Okay, it is going to create a process. We know that a process is an application which is under execution, which is an exact image of that application executing, right? So whatever the flexibility we have for the server, all flexibilities will be there with this new process also. Now, after creating this process, now what the concurrent server is going to do is this concurrent server is going to assign the client to this process. And now this process is going to take care about this client. And now your concurrent server is nowhere involved in the execution of this process. Means, suppose if I have one more client sending a request, suppose I say we are having a request from another client. Again, what my concurrent server is going to do? The concurrent server again is going to create a process, and then that concurrent process is going to assign the task of this client to that server. So now with this scenario, now if you have n number of requests, your concurrent server is going to create n number of different child processes are going to be created, which is going to handle the client. So it is about your iterative server as well as your concurrent server. So nowadays only concurrent servers are in use because mostly we use the concurrent servers. Okay. Now we'll see how we are going to create a server, how we are going to create a child, okay, in your programming of your C language. Okay, now we'll see what are the functionalities we have, what are the header files we need to include as a part of your program so that we can create, or we can, what you say, generate a server as well as the client, and also we'll see the interaction between your server as well as your client. Now we'll see what are the header files first. So whenever I want to implement your, sockets or socket programming, what I should do is I need to include the header file called system/socket.h. Okay, it is the very important header file which we need to include, and then we are going to include net inet.h. So it is one more header file which has to be included. So whenever I use my internet protocol there. So these are the two header files which we need to include whenever I want to design a program for the server as well as my client. Okay. Now, as I said earlier, whenever I want to send or receive the data from the internet, first of all, we are going to create a socket. So now what I need to do, we need to create a socket. As I said, a socket can also be called as an endpoint. Now, for creating this endpoint or for creating this socket, we are going to have a separate functionality. Okay, now we'll see what is that functionality is or what is that function is. So we have a separate function here, and so we call that function as a socket function, which is going to take some arguments into it. What it does, it is going to take some arguments. Now we'll see what are the arguments it is going to take. Just I will increase the font of it, or I should decrease the font, right? Yeah. Okay, first I'll put it here. Okay. Now, whenever I want to create a socket, so we are going to use a functionality called a socket, which returns an integer value. Okay. Whenever I get a positive number from this function or this system call, okay, I'll say that we are able to successfully create an endpoint. Otherwise, if it is a negative, it means that I cannot create an endpoint for it. Okay. So this socket function is going to take three arguments. Number one, the first argument is the domain. The second argument is the type, and the third argument is the protocol. Now we'll see what is the domain now. So when I talk about when I talk about this domain, we need to specify to which address family or which address family I will be using when I communicate the data with another computer. So we are going to specify the address family of it, whether we are using IPv4 or whether I am using your IPv6 or whether I am using your, any other raw sockets. I need to specify as your start. And so what your domain is going to specify about, your domain is going to say the address family. What it does, it is going to talk about your address family. Then you will be asking how many address families are there, right? So we have IPv4, we have IPv6, we are going to have the raw socket also. It means we are not going to use any address family, then we are going to, so if you are going to communicate only with your, base Linux or Unix environment, then we are going to use my address family of the raw also, right? And the second type is going to specify, the second argument says it is the type, whether your communication network is a connection-oriented network or it is a connectionless network. So the second argument says whether it is a connection-oriented or a connectionless. Connection-oriented, it means that it is going to implement the protocol called TCP protocol. If I say connectionless protocol, it means that it is going to implement your UDP protocol. We know what is the acronym of your TCP protocol, which stands for Transmission Control Protocol. And your UDP stands for your User Datagram Protocol. So if I use my transmission control protocol, I say this is a reliable network. It is a reliable network. Whereas when I use my UDP protocol, I simply say that it is an unreliable network. Okay. So basically most of the applications, right, which need some reliability, or if you expect some sort of security, or if you expect some sort of reliability on data transmission, most of the applications are going to use your TCP protocol. So whenever you use your TCP protocol, the advantage of this TCP protocol is that it is going to create a virtual circuit is created between the sender and as well as the receiver, and the data transmission is being done only through this virtual circuit. So the second argument of my function socket says whether we are going to use your connection oriented network, or it is going to say whether you are going to use your UDP protocol or connectionless protocol. It is about the second argument. And coming to the third argument, it specifies um, uh, which protocol we are going to use, right? Means, so we have the flexibility of using. Suppose I say, if I am using my socket, I mean, if I'm using my TCP protocol, then what we are going to do is I'll be saying IP proto underscore TCP. If I am using my UDP protocol, then we are going to use my UDP protocol. See, now if you can see this word, what you are going to do now, we are going to integrate your IP, your internet protocol is being integrated with my TCP as well as my UDP. Okay, so whenever I want to combine these two things, then we are going to specify IP proto underscore TCP as well as, or it may be sometimes it is called as my UDP. You know why we are going to use your IP protocol. IP protocol, whenever you want to send the packets onto different networks, right? So from one network to another network, then we are going to approach, or then we are going to take the help of your internet protocol. Then I say, whenever I want to send the data across the networks, then we are going to use your IP protocol. Then we use your TCP protocol as well as we are going to use your UDP protocol. So with this information now, we know now what is the use of my socket. So socket is a function which creates an endpoint from where we are going to communicate with the outside world, which is going to take 3 arguments into this function. So after the socket, then now we are going to talk about one more important function as bind. So what your bind is going to do, we'll see. So this bind is also a function, right? It is also a function, and we'll see what that function is going to do now. This is also a function. First of all, we need to understand, to say, arguments of it first, then we'll go forward what is the functionality of it also. Okay. What this if you can see this function, right? If you can see this function is going to take 3 arguments, right? Socket FD, and then it is going to take the address of my socket address, and then it is going to take my third argument as my address length. Now we'll see what are these arguments. Okay, very simple arguments again. This socket FD is the value which is being generated by your socket. Okay, so whatever the integer value which is generated by the socket is being treated as your socket FD. And then coming on to my socket address, so it's a structure. So if you can see this argument carefully, it is been like a structure. So when I say it is a structure, it means it contains some variables in it. Okay. Now also we'll see what are the variables of this structure. So if I go through this structure, so if I go and see this structure, so we have the structure, we are also going to understand what is that structure also, so that we will be having an idea, right? What are the variables of it, where we are going to use all those things, we are going to understand, right? Again. So this is the structure, right? So this is the see, SOC address is the superstructure. I mean, this is what you say. So this is my socket address, and inside this socket address we are going to have another structure, and this structure I'm talking about. If I'm creating a variable of this, if I'm creating a variable of this structure, it is understood that we are creating a variable of this structure also. So now we are creating a variable of this structure. It means that implicitly it is understood that we are creating a variable of this structure also. Now we are going to understand what are the variables which are there in this structure. So first of all, the first variable which we are going to have is SIN, socket SIN family. Okay, so now we need to understand to which family you are going to belong, we are belonging. Whether You are sending the data by using your internet protocol, or you are sending the data by using the Unix protocol. So mostly we are going to use only internet protocol. So we are going to say address family AF address family underscore INET is the value which we are going to store into this one. Then SIN port. As I said, a port is going to separate the application. It is going to separate the application which wants to interact with outside world. So it is SIN port. Then SIN address. So what is the IP address of your computer? So it should be stored in this variable. Then 0. This is used for padding purposes, but for now we are not going to use any padding, right? So for this socket, so we are going to create a variable of the structures. Of this structure, we are going to store some values into this structure, and then we are going to give the address of this structure as an argument, as a second argument into the function called as a bind function. And the third argument into the function which we are going to send is the address length. So what is the length of my structure? So it can be calculated by using my size of operator. So these are the three arguments which we are going to pass into my bind function. Now we are going to understand, okay, actually what is the purpose of this bind function, isn't it? So first of all, we need to understand what is the purpose of my bind function. So this bind function is going to assign an address to a socket. So whenever you want to assign an address, that address will be an IP address. So whenever you want to assign an IP address onto a socket, then we are going to use the functionality called as your bind function. So unless we assign an address onto the socket, that socket cannot communicate with the outside world. So whenever I want to communicate with outside world, what I need to do? I need to have a socket, and the socket should have a valid IP address, and also it is going to contain a port number. So it is about the second important, what do you say, the functionality which I use here in network programming. And now coming to my third, now we are talking about the concurrent server. So when I talk about the concurrent server, it means that we are talking only about the functionalities which are to be there as your concurrent server. So now we'll see what is third function we are going to use for your concurrent server. So your third function or the third functionality I use in my socket programming is my listen function. What is that? It is a listen function. What this listen, it is been used only by your what you say, TCP servers only. It is been used only by the TCP server. So what it does, it is going to take the socket empty as the first argument. We know what is the socket empty. And the second argument which we are going to pass into this function is backlog, which specifies the size of the queue. Queue means it specifies how many number of clients it can handle. So this specifies, suppose if I say 5, if I say specify 5, it means that your server, your TCP server can handle only 5 clients. If I can even increase the number, and that number can be of my 1024. So it depends upon the computer on which we are executing your program. So after this listen function, right, now we are going to have another function here, and that function is called as your accept function. What is that? That function is called as your accept function. Now we'll see what are the arguments which we have into this function. So the arguments, which I have, so the arguments which I have for my accept function is, so before going into the functionality of this accept function, so what this accept function is going to do is, this accept function is going to take the connection, take the request. What it does, it is going to take the request from the client, okay, and then after taking the request from the client, it is going to establish the connection, establish the connection with the client. So the connection establishment is done. The connection establishment is done at the point of executing the function called as accept function. So this accept function is also going to take three arguments. The first argument is your socket function. We know from where we are going to get the socket from the socket function. And we are going to take the second argument, right? So into which structure variable we are going to take the request. Means your client is sending the request. So whenever a client is sending the request, it means that it is going to send its complete information with the help of a packet. So that packet is going to contain the IP address, that packet is going to contain the family, that packet is going to contain the port number. So the address of a variable we are going to specify here, which will hold the information about the client on which I want to communicate. Okay, so this is there as the second argument. And the third argument obviously will be treated as my the structure length of my structure. So these are the three arguments which we are going to use, right, whenever I call the method called as your accept function. Now, if you go further, right now we are going to see what are the other functionalities we are going to have. Then we are going to have one more functionality here, and that functionality is my connect function. But it is your connect. It is also, again, it returns an integer value. If I'm able to establish the connection successfully, then we are going to return a positive value. Otherwise, it returns a negative value. So the first argument again will be the socket FD, we know. And then we are going to have your structure address. So now which socket address we are going to have now? Address of the server to connect. Okay, so this contains address of the server which you want to connect. So now the client address is there. Where it is? Client address is there in the structure variable, in this variable, and the address of the server is there here. So now these two structures or these two addresses are going to communicate with each other. Okay, this is of the client and it is of your server. So these two IP addresses are going to communicate with each other. And obviously the third argument will be the size of my structure. So now, first of all, we are going to use your socket, then you are going to use your bind, then you are going to use your listen, then you are going to have my accept, then you are going to have the connector. Then after connecting, after establishing of the connection, okay, after establishing the connection, we are going to have the functionality which is going to read the data as well as which is going to write the data also. Or I say, I want to send the data or I want to receive the data also. So whenever I want to send the data, what we are going to do, we are going to use a function called send function. So send is the function which we are going to send the data onto my socket. And which is going to take my socket FD, which is going to take the address of the string in which we are containing the data. And then we are going to specify the size of the data or number of bytes which I want to send. And the fourth one is the flags. Whether I want to wait for another processes, whether I should not wait, whether it is important, whether it is urgent, all those things, flag will be there as my fourth argument. So it is about the functionality called as my send function. So along with the send, whenever I want to receive the data, Now we are going to use a functionality here, and we call that functionality as, see, this function. Yeah. So now this is going to have a function called receive, and socket FD is there, into which variable I want to read the data, what should be the size of the data, and then we are going to specify which flag, whether I should wait for others or whether I should not wait for others, or whether it is an urgent. All those things will be specified as my flag. So now, and after sending and receiving the data, now we are going to have a very interesting function called as my close function. What my close is going to do, this close function is going to close your, what it does, it is going to close the connection which has been established, So these are the functionalities by which we are going to communicate with another computer which is there over network. Now we are going to see a simple, what you say, a diagram by which we are going to create, or we can remember this one very easily. So first of all, we are going to use the functionality called as your socket. So after successful execution of the socket, then we are going to use a functionality called as bind. And then after executing your bind, then we are going to use a function called as listen. So after executing your listen function, then you're going to have the function called as accept. After executing that accept, then you're going to use a function called connect. After connecting, then we are going to use a function called receive. After receiving the function, then we are going to have a function called as your closed function. After receiving and close is been done, then we are going to use the function called as close, which is going to stop your execution. So these are the functionalities which will be a part of your socket program whenever I want to send the data from one computer to another computer. And these functionalities are used for creating your server. Now I want to create a computer, or I want to create an application which is going to create a client. So whenever I want to create a client, we are going to use my socket as it is. Okay. We are going to use my socket as it is. And after using my socket, then what we are going to do is we are going to send a request. Okay. Long here. So what I need to do is, yeah. So what we'll do, like after the accept, then we are going to have the receiving only. Okay. Now coming on to my client side, right? So what my socket is going to do, it is going to create an endpoint, right? After the socket, then we're going to use a function point. So after the connect function, okay. After the connect function, then we are going to say send. Then we are going to say the function called receive. Then we are going to use function called close. Now, connection establishment. See, so the connection established. So whenever I say connect, okay. So whenever I say connect, so we are going to send a request, and the request is being sent onto my acceptor. So if the server is going to accept the connection, then we are going to establish a connection, or virtual circuit is in being established between the server and the client. Then there will be the sending, and there is the receiving. Means that now we are going to send the data in this direction, then we are going to receive the direction, vice versa. So these are the basic functionalities which we have, or whenever I want to send the data from one computer to another computer. So these are functionalities which we are going to use. Okay. right? So as I said earlier, so we have the header files like stdio.h, lib, string, socket, ARPANET, and standard, universal standard header files. They need to be included, right? And then one, as I said in the beginning, along with the IP address, we need to specify the port number. So what I do is I'll define a constant value of 8080. And then we are going to specify the size of the buffer, where we'll specify the amount of size, the amount of data I can read and I can write onto that network. I am going to specify this as 1024. It's our wish. It depends upon uh, uh, requirement of the construction of your server. What I do is I'll just write the main program, right? As you all know, and we are going to create two variables, okay? And we are going to create an address variable. We are going to calculate the size of that address. Now, this structure is defined uh, in your socket.h, right? So if you don't include this header file, it is going to specify that it's an error, okay? Then we are going to initialize this as 0. Then we are going to create a string called hello server. And what I do is now here at this point of time, I create a socket and we'll see whether it is a positive one or not. If it is zero, it indicates that it is a successful creation of the socket. So we are going to send 1, 2, 3 arguments, as I said. It means we are going to use my TCP protocol here. Then it is IP proto underscore TCP. Okay. Then if I'm unable to create an endpoint, then I'll say socket failed. Okay. Then we are going to fill this structure, right? I'll say address family of internet. Then see in address any, which it is going to listen to all the addresses over network, right? So I can even restrict this address to only one IP address also, instead of using in address underscore any, right? If I specify this option, it means your server is open to all, right? If I want to confine your server only for only a specific IP address, then we are going to use the IP address of the device so that I can establish the connection between that computer and your computer. Okay. Then we are going to use the port, and while using the port, we are going to use some function here called H2NS, where host to network short. Means this number 8080 has to be compatible to be stored into this variable, right? So this variable is my U short. It is U underscore short variable. So we need to typecast that variable. So whenever I want to typecast that variable to this number, I'll use the function called H2NS. Okay. Yeah. After that, we are going to bind it, right? So we are going to assign the IP address onto your socket by using the method called bind. And if I'm unable to do it, I'll say bind failure. Then coming to the listen, as I said, it is going to take two arguments, the socket FD, and it specifies the size of the queue, the size of the backlog, the number of clients I can handle, right, at a single point of time, that is 3. So we are going to say it as 3, right? Yeah. After that, what we are going to do is now we are going to use a function called acceptor. It means now whenever accepting means now I want to establish the connection from the client to your server. So we are going to use this functionality to establish the connection between the client and the server. Okay, that's done. So now I think now you are able to understand how we are going to establish the connection between your client and server. Now I want to send the data now. Okay, now I want to send the data. So whenever I want to send the data, so as I said earlier, we are going to use some functionalities like read and write. So now we'll see how we are going to use those read and write now. So see here now what I am going to do now. I want to read the data. So whenever I want to read the data, so I use the method called read, okay, and I store the data into the buffer, and then we are going to send the data which is there in this string to the client, and then we are going to close the connection. And while closing the connection, we are going to use the close a new socket as well as my socket. So this is the program, right? This is a program by which we are going to establish a server. Now we'll see the code for your client now. A very simple code, almost a similar code which is there for your server. So in the cloud, in the client, what I do is I'll just use my socket. I'll just use my socket. I'll use my same port number. Okay. I'll use my client address. Okay. Then I'll connect it to the server. Then we are going to send the data and read the data uh, from the server by using some functionality. Now we'll see what are the functionalities I have now. So I say now socket. Again, we are going to use my socket here, right? I'll be using my socket. I use my socket string. Then inet. Okay. Then port. Okay. Again, the same, whatever the things which we have done in your server, we are going to do the same. This is interesting here now. Now, see, 127.0.0.1 is the address of the server onto which I want to connect. Okay, so your client wants to connect to this IP address. Okay, so we need to specify this IP address, and this is a functionality, right? INET protocol P2N, port to network. Okay. So what we are going to do now, we are going to convert your IP address into the string so that I can establish the connection, and we are going to store that into this address. Okay. So whatever the IP address which is there here will be stored into this variable. Then what I do now, then we are going to use the function called as a connective function. So what this connective function is going to do, it is going to establish the connection with your server, right? And then we start reading. Then what we'll do is we'll start reading the data. We start sending the data by using the send method, and also we are going to use it by using my read method and all. So these are the functionalities by which we are going to establish your server as well as my client. Once again, we are going to revisit the diagram. So after, yeah. So now if you can see this diagram now, you'll be having an idea. So first what I have done, I have created a socket, then we have a bind over there, and then we use the listen function, accept, receive, and send. And here what I'm doing, I'm creating a socket, we are going to create a connect, you are going to create a send, the receive, and close. So now this is the sequence of functionalities. So whenever you want to create a server, you need to follow this sequence, and whenever you want to create a client, we are going to create this sequence. So if we are going to if you are going to execute these functions in this sequence, right? So before client starts, okay, the server should exist. It means we need to execute the server first. Then only I can go for my client. So if you execute your client before the server, the connection will not be established. So what we need to do? So we need to establish, or we need to execute your server first, and then we need to go to your client for sending and receiving the data between your client as well as your server. So this is how we are going to establish the connection between your client and server. Okay, so previously we understood how a TCP server and how a TCP client is going to work, right? Now we are going to understand how exactly your UDP server and client can be created. We'll see. So our intention is to create a UDP server. So all these header files are common as we have for your TCP server. And also we are going to talk about the port number, the buffer size. So now one interesting thing we need to have here is that we are going to, whenever I talk about my UDP server or UDP protocol, we need to have a separate variable for a server, and also we are going to have a separate variable for the client. So whereas in my DDP server, what we have done is that uh, we have only one address, and with the help of that one address, we are able to manipulate things and we are able to send the data, receive the data, and all those things were happening. But here, we need to have two separate variables where we are going to hold the addresses of server and the client in different variables here. Then, it is the data which I want to send from the client to your server. Now, so in the socket, if you can see the second argument here. So if it is your TCP protocol, I say socket underscore stream. Whereas if I use that argument like socket underscore dggram, a datagram, so it means that we are implementing a protocol called as a UDP protocol. Okay. Then, as we all know, right? Then, and we know the importance of this in address underscore any. It means that your server is open to connect with any client which wants to have the data from the server. So that's the importance of this argument, right? And also we know the importance of the functionality called host to network shortcut. So which convert your port number, because we have the port number as 8080. So this 8080 can't be stored in my ushort variable, right? So for storing the data into this ushort variable, we need to typecast that value to ushort. So it can be done by using the method called htns, right? Then we are going to bind that address, and while binding that address, we are going to use my server address, right? So while binding your address, we are going to use your server address into your bind. And while receiving, right? So while receiving the data, so after calling the binding function, now we are going to read the data. So whenever I want to read the data, then we are going to use the method called receive from. So we have the socket FD, we are going to specify the buffer, maximum buffer, 0 flag value. Then see here now, we are going to take the address of my client here. It means that whatever the client which you like to interact with your server, so the address of it will be stored into my client. Okay, then we are going to have the address length. Okay, so we are going to calculate the address of the variable called as address length and all. So this is how we are going to read the data or take the packet from the client to the server. And when I want to send the data to the client, I use my method called send to. See again here. So I use my client address, right? So I'll use my client address. So I'll be sending the data to my client. So while sending the data from the server to the client, the packet which is going to take the data from the server to the client, right, will store the details of the server. So at the client end, while reading the data, if I open the packet, you can even find the IP address of the server, IP address, port number of the application which is listening to you, which is taking the data, which is sending the data. All those things I can explore things. Okay. So in the further videos, what I'll do is I'll take out that packet and I open that packet for you, and we'll start analyzing what is the importance of each and every item which is there in that packet. Okay. Right. So this is about the functionalities which we are going to have in your server. Now we'll talk about the client. And if I talk about the client, again, all these things are the common header files which we are going to have. We use a port number, size, see here now. So I use only the server address here. Whereas in my server, what I'm doing now, I'm using my client as well as my server. Whereas in my client, I will be using only my one variable. Okay. Then again, the socket function is going to take your, the option as a dggram, because I'm implementing the protocol called as a UDP. And if I'm able to create a, a socket, it gives a positive number, or sometimes it may retain a value of 0. It depends upon the environment on which we are executing your program. Okay. Then I'll specify the family there. Okay. Then we are going to specify the IP address of my server. And then we are going to send the data to my server. And then we are going to receive the data from the server. It means now the communication of the packet is being done between the server and the client in the form of a packet, along with the data, along with the information which is transmitted from the server to the client to the server. The transmission is done in the form of a packet, which holds each and every item of the server as well as the client. Okay. So then with this, we are going to close the socket by using my close function. So these are the functionalities by which we are going to send the data as well as the receiving the data. Now we are going to see some of the key differences we have. Okay, so we have few key differences. Now we are going to explore what are those key differences between the TCP protocol as well as your UDP protocol. So as I said, your connection oriented, I call it as TCP, and connectionless, I call it as my UDP. Meaning, connection must be established before data can be sent. So whenever I want to send the data, first of all, we need to establish the connection between the server and the client. Whereas your UDP, whenever I implement my UDP protocol, as I said, it is a connectionless protocol. Okay. When coming to the reliability, okay, TCP is reliable, meaning that it guarantees the delivery of the packet and delivery of the packet, and it is done without any errors. Whereas coming to the UDP protocol, it is unreliable. It means we cannot say that the packet may reach in a specific amount of time, and we cannot say that it will not contain any error. So all those things will be a part of the packet which is designed for my UDP protocol. So these are some of the advantages and disadvantages of your TCP as well as the UDP protocol. So socket programming in the end, so socket programming is a fundamental concept in network programming. It provides a powerful way to create network applications that can communicate over a local network or an internet. Understanding the concepts and the functionalities involved in socket programming is essential for developing the robust and effective network application. That's all in this video. Dara. So now we'll see some of the byte ordering functions which we come across very frequently when we talk about this socket programming. So those functions we have are like we have those functions. We'll see what are those functions and understand what exactly they are going to do for us. Okay. The first function we have is H2NS, right? Where it stands for host to network shortcut. Okay, so what it does, it converts 16-bit or 2-byted data from host byte order to network byte order. Hence, we are going to change the order of the bytes, right? So, because see, whatever the byte we assume here, it will not be followed while sending the data over the network. So, we need to change the data according to the byte order. So, for changing the byte order, right, then we are going to use the method called H2NS. And along with the H2NS, we have another function called H2NL, where it stands for host to network long, right? So what it does is, instead of taking 16-bit here, it is going to take 32-bit of data, or I simply say 4 byte of data, and which is going to change the order of it. Okay. So we use this for converting a string, or if you have an IP address which we have a number separated by a dot, right? Then we use the method called H2NL. Then after this H2NL, then we are going to have a method called N2HS, where we start we call it as network to host shortcut. So if you have only a 16 bit of data, then we are going to convert them to post short, right? In the reverse order, like H to NS. So N to HS is the reverse of it, right? So we are going to take your network byte order, and then it is going to convert the data to my post byte order. And in the same way, we use my N2HL, right? So it is also going to take the data from the network byte order, and then it is going to convert it into the post order, right? So these are the functionalities which we are going to have very frequently, which we are going to use, and that is going to help while sending the packets in the correct order from the server to the client and client to the server. Meanwhile, right, and also we are talking about the byte order. Now we'll see what exactly the byte order is. So an arrangement of bytes when data is transmitted along the network, okay, is called as byte ordering. And different computers is going to use different byte ordering functionalities, right? When communication is going to take between two machines or two computers, two electronic device, so byte ordering is a compulsory event which has to be done or implemented to have a correct sequence of bytes. Generally, an internet protocol will specify a common form to allow different machines byte ordering. TCP is the suit or the standard by which we are going to say order the bytes. So we are going to have two types of byte ordering uh, items are there. We call them as Big Indian and Little Indian. When I'll talk about your Big Indian, higher order bytes are stored on the starting address, and the low order bytes are stored on the next address. And talking about your Little Indian, lower order bits are stored the starting address, and higher order bytes are stored on the next order. So this ordering has to be matched, right? So if you don't match these ordering functionalities, so whatever the output we are expecting will not be there as it is, right? So what we need to do is, so for having a correct output on the server as well as on the client, we need to have these byte ordering functions.